Hi guys, this is the video for Chapter 9, Lesson 5. So in this lesson, we are going to be talking about something called scientific notation. And I would say that this is the kind of exponent forms of numbers that you will come into contact the most in your daily life, and especially when you get into some higher level science classes. And potentially even in your careers. So let's just talk a little bit about what the basics of scientific notation are. So if I had a number 10 to the third power, how would I break this down? Well, that would be 10 times 10 times 10, right? Which ends up being 1,000. So what you notice is whatever the power is for your number, if it's a 10 to a power, that's how many zeros you're going to have. So let's say 10 to the fifth power. That would be 10 times 10 times 10 times 10 times 10 times 10, 5 times, right? So that would have 1, 2, 3, 4, 5. So that would have 5 zeros. And don't forget to put your comma. So that's 100,000, right? So you get the idea. Whatever the power of 10, whatever 10 to whatever power is going to be that number, basically with that many zeros, okay? So basically what scientific notation is just a way to rewrite a number that's either really big or really small. So let's say I have, I don't even know. 12,734,690, okay? This is a pretty big number. So how we can write scientific notation is basically to turn this number into a number between 1 and 10 by placing a decimal. Then multiply it by a power by 10 to a power, okay? So let me work this out for you. Basically, we're gonna put a decimal in place of this number that makes it between 1 and 10. So now this is 1.273469, just still a long decimal, right? So I'm gonna put a decimal to make this a number between 1 and 10. And I'm gonna do away with the zeros because those are just placeholders. So I'm not even gonna put that there. And I'm gonna multiply that by 10 to a power. And the way we do this is we're basically gonna multiply and think through how many places do I need to move my decimal for it to be in this original form of what this number was supposed to be. So I have 1, 2, 3, 4, 5, 6, 7. And so because of that, I'm going to multiply that by 10 to the 7th power, okay? And that is this number in scientific notation. So the original number is what we call standard form. Standard form. So this is standard form, the original number. And then when you multiply it by a power, that's called scientific notation. And so this comes into handy because there are times when we interact with really big numbers or really small numbers, and we don't want to write the entire number out. Now, this example wasn't the greatest because I really did have to still write out all these numbers. But let's say we have 0.000000025. Okay, lots of zeros, 6 zeros in between. So the way we would write this in scientific notation is the same idea. We're moving our decimal so that this becomes a number between 1 and 10. So that means I would place my decimal 2, 3, 4, 5, 6, 7 to the right, which makes my decimal right here. So I would write this as 2.5 times 10 to a power. Now, however, if in my original number it's becoming smaller, or my scientific notation when I multiply it, the original number is smaller than a number between 1 and 10, then I really have to move my decimal to the left. Then I would be multiplying it to a negative power. So this would be to the negative 7th power. That way I know I'm moving this direction 7 places. When I'm multiplying by a positive power, that means I'm moving this direction 7 places, okay, to the right 7 places, because my number is getting bigger, right? You can think of, well, when something's being multiplied by the negative, it's becoming smaller. So you're going to move your decimal to the place where it makes your number smaller. So let's try a few practices on your study guide. On here, we're going to take a look at a few of these problems, and there's some examples up here that you can kind of look at if you want to. But basically, we're going to write these numbers in standard form. So what we're going to do is multiply it by whatever. Really what you're doing here is 4.12 times 10 times itself 6 times, but instead of writing this, 10 times itself 6 times, we know that this is just 1 million, right? We're just multiplying it by 1 million. And so when you multiply it by a million, you're actually going to move your decimal 6 over. So this becomes 4, 1, 2, move your decimal 1, 2, 3, 4, 5, 6. And if you want to draw, your little and count them out, you can. 1, 2, 3, 4, 5, 6. So that is your answer, and that's it. Okay, looking at this next one, we're multiplying by 10 to the 2nd power, so we're moving our decimal 2 to the right. So this becomes 580. Okay, to the negative 3rd power, so we're going to move it to the left. So 1, 2, 3, that's where your decimal would be. So it's 0 point, and then 1, 2, 2 zeros, 1, 2, and then 9, 0, 1. Ooh, this one's a big one. So I'm going to do it over here. Moving your decimal over 7 times to the left. 1, 2, 3, 4, 5, 6, 7. So that means I'm going to have 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. And then 6, 7, 2. So it's 0.000000672. Okay, so let's do 2 more. Let's do 8 and 7. Do a positive and a negative exponent. So to the 9th power, so moving this 1, 2, 3, 4, 5, 6, 7, 8, 9. Put your commas, and that's your answer. Moving this 4 to the left, 1, 2, 3, 4, decimal 0.000348. All right, let's try writing these numbers now in scientific notation. So what you have to do here is basically turn your number into a number between 1 and 10 by placing your decimal there, and then multiply it by 10 to a power. So with number 10, I would put my decimal between the 1 and 2. Then I have to think through, okay, I have to move my decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 places. So this is going to be 1.2 times 10 to the 10th power. Okay, this is going to be 5 times 10 to the 3rd power. All right, so I put my decimal here to make this 4.75. That's between 1 and 10. I have to move it 1, 2, 3 to the left. So times 10 to the negative 3rd. Okay, let's do this one, and this one, and we'll call it good. So number 14, 2.35. We have to move it 1, 2, 3, 4, 5 times to the right, so 10 to the 5th power. Small number, decimal, making this 4.03. moving it over 1, 2, 3, 4, 5. So to the negative fifth power. Don't forget to make it a negative if you're making it a decimal. Same here, looking at this as 1.3 times 6, 7, so 10 to the 7th power. All right, good job. So I've had students say, well, why do I have to make it a number between 1 and 10? Well, doing these next few problems is going to tell you why. We in math like to keep things consistent. I don't want to do something where someone else does it a different way, and then the format of how we work out our problems is not consistent, and then we have to figure out, okay, what did you do here to get what you got? What did you do here to get what you got? We want things to be consistent. So one of the reasons why we want to make sure our numbers, we're writing it as a number between 1 and 10, is because it helps us compare numbers a lot easier and a lot faster. So if you had a number, let's say example A here, I'm going to write this down on the side, 2.097 times 10 to the 5th power, as opposed to 3.12 times 10 to the 3rd power. Well, because you know that both of these numbers are between 1 and 10, you can immediately say, oh, 2 is bigger than 3, so 3 is bigger, but then you can now look at the power and think through, oh, well, I'm multiplying it by 10 to the 5th power, so I'm moving my decimal over 5 times, and so let's find out which one's going to be bigger. 1, 2, 3, 4, 5. So this will be 209,700, and then this would become 1, 2, 3. This would become 3,120. And so you can look at this and say, I'm moving my decimal 5, I'm multiplying it by 10 to the 5th power, which I'm multiplying it by a bigger number, even though it's 2 point something, it's smaller. I think I still am going to get a bigger number, okay? And so you can look at the power and kind of say, well, because my decimal is in the same position for both of these numbers, if I'm moving this 5 times over, this number is going to be bigger. So 2.097 times 10 to the 5th power is greater than 3.12 times 10 to the 3rd. Now, if I didn't write my scientific notation where my number was between 1 and 10, and I wrote it as, this, as opposed to 3.12 times 10 to the 3rd, wouldn't this be a different story? Because, well, actually, I'm going to rewrite this differently. Let's say I wrote this as 2.097 times 10 to the 5th. And then this I wrote as 312 times 10 to the 3rd, right? So my decimal is not in a consistent place. So now I really have to spend more time to think through, okay, I have to put this, 5 over, so it's the same number here, but then this one would be 3 over, and then this would be bigger, I think. Or maybe not. No, yeah, this would be bigger. Right? So having a consistent place that your number scientific notation is always between 1 and 10 actually helps you recognize the value of your number a lot easier and a lot faster. And so that's the reason. Consistency helps us work faster. When things are not consistent, you slow down. Just like if, things in your house are consistently in the same place, it takes you less time to find it. Whereas if sometimes you put your keys on a hook, sometimes you put them in your pocket, sometimes you put them in your bathroom, you have to go through and think through, oh, where did I put my keys, or your wallet, or your water bottle, or whatever, right? Or your math book, right? So having consistency helps the process of things getting done faster. So what you're going to do here is basically compare the numbers and then decide which one is greater. And I'm okay if you circle them. So when you look at this, I've got 4.9 times 10 to the 4th power, and then 9.9 times 10 to the negative 4th power. So when I look at this, even though my number here is 9.9, because it's to the negative 4th power, I automatically know this number is going to be greater. Okay. So I'm okay with you just circling what you see is greater. And right here, it looks like this one is greater, right? Because it's to the positive third power. This is to the negative second power. So you can pause and work through these if you want to. So looking at this, I'd move my decimal 1, 2. So I think through I have 320 compared to 700. I think 700 is bigger. 0.002 and then 3.6 times 10 to the negative 4. So I might actually have to work this one out. 1, 2, 3, 4. So this actually has 3 zeros in front of the 3, 6. Instead of this has only 2 zeros. So I think this one's greater. Okay, so now what you need to do here for 5, 6, 7, and 8 is order these numbers from least to greatest. Make sure it's consistent, that it's least to greatest. And I'd like you to put a little less than or less than sign in between each number to show this one's smallest and then this one's bigger, smallest, bigger, smaller, bigger, right? To show kind of the progression there. So I'm gonna think through, I might look at what I have here. And this one's the greatest. So I'm going to say, well, I'm actually going to look for the smallest one. This one's the smallest. I'm going to say that's number 1. And then I have these two I have to compare. This one's the greatest. So that's the 4th number in my row. And then I've got 6.9 times 10 to the 3rd and 7.1 times 10 to the 3rd. So this one's going to be greater. So this is 2 and 3. So now I'm going to write 7.6 times 10 to the negative 6. And then 6.9 times 10 to the 3rd is less than 7.1 times 10 to the 3rd is less than 6.8 times 10 to the 4th. So on your homework, I want you to write your answers out where you're showing each number with a less than or greater than sign. Okay, I'm gonna actually probably write my answers down here because it's hard to squish them all in here. Maybe I'll make this a little bit bigger too. Okay, so looking at this smallest, so both of these are to the negative 8th power, and this is 4.02, this is 4.0, so I think this one's gonna be smallest, then this one's the second smallest, and then here's another negative, oh yeah, there's a negative power, so 3 and then 4. So I'm gonna write this as 4.0 times 10 to the negative 8th less than 4.02 times 10 to the negative 8th times 4.15 times 10 to the negative 3rd less than 4.2 times 10 to the 2nd power. Okay. Now some of these numbers, you might have to rewrite it in scientific notation for you to compare. Okay, so I might have to look at this as 8.16 times 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th power and think through, okay, in comparison to everything, is this greater or smaller? I think this one's greater, right? Greatest, actually, because it's to the 7th power. And then you could work those out. So same thing here. For 8, you'd have to rewrite these probably in scientific notation and then compare them. I'm running out of room here, so I'm just going to stop here because I think that's probably enough examples that you understand what's going on. And you can also look at your book if you need to. And that's all I have for you.